Greetings, one and all, and welcome to this math video. Today, in this math video, we'll be considering this question on vectors. And here we have a four-sided figure, right, with four vertices, A, B, C, and D. And we call four-sided figures, what's the name for four-sided figures? What is the name? What is the geometrical name? Well, we call them quadrilaterals. Right, so here we have this quadrilateral in front of us, and notice they tell us that in the diagram, AB is actually equal to B plus C. So AB equals B plus C. And they tell us that, hey, BC is actually equal to 5B. And they also tell us that AD is equal to 3B minus 2C. And they're saying, using this information, in light of this information, express AC and DC in terms of A, B, and or C, and make sure it's in simplest form. And the next thing that they want us to do is, they're saying, hey, look at the vectors A, B, and look at the vectors DC, and tell me, what are the geometrical properties that you can get from these vectors? Or what geometrical properties that hold for these vectors? Okay, so let's consider the question BI. Let's look at it. And we're trying to figure out what is AC? How can we find AC? Well, note that if we say in AC, well, AC means, right? AC means that we're going to start at A and we're going to end at C, right? We're going to start at A and we're going to end at C. And so how can we reach that destination? Well, we can go from A to B, and that's why we have AB here. And then we can go from B to C, and that's why we have BC here. So AC is actually equal to AB plus BC. But what is AB? Well, AB is B plus C, and that's why we have B plus C here. And what is BC? Well, BC is 5B, and that's why we have 5B right here. So AC equals to B plus C plus 5B. All right, can we simplify? Can we do something here? Of course we can. Let us group our like terms. So here we have a B here. Do we have any other B's? Which we put place here? Yes, we do. We have this 5B here. So we're gonna take this 5B and put it next to our B there. C is the only C term that we have. And so we're going to take it and we're going to put it on this side. It's all by itself. So we have 5B plus 5, sorry, we have B plus 5B. And they are like terms, and so we can perform operations with it. What is B plus 5B? Well, B plus 5B is actually going to be equal to 6B, because you can think of this B being 1B, right? You can think of the invisible 1 here. So this is 1 plus 5, and what is 1 plus 5? That's 6. And we tack on the B there. Plus C. So AC is going to be equal to 6B plus C. We just bring the C down. And there's nothing that we can do here because these two terms are unlike terms, and we cannot add unlike terms. Okay, there we have it. That's BI. We've completed that. What about BII? And in BII, they want us to determine, hey, what is DC, right? In terms of these variables. A, B, and or C. So let's start. So what is DC? What is DC? DC means, right? DC means start from D and find your way to C, right? Start from D and find your way to C. Now we can go from D to C, but the problem is that we don't have an expression for this line. So we have to go the long route. So we're gonna start at D and go to A, and that's why we have DA. And then we're going to start at A and go to C. And that's why we have AC here. So let's do that. What is DA? What is DA? Well, yeah, so here's DA. DA is this direction. We know from the question that AD, and you can see the arrow, AD is heading in this direction. Right? That's the direction that AD is heading. AD is heading in that direction. But we don't want to go in that direction. We want to go in the opposite direction. And so I'm going to represent that with this baby blue symbol. we want to go in this direction, all right? So that's D8. We want to go in that direction, right? We want to go forward, not to the right. We want to go forward, more to the left, right? And so we want DA, but DA is opposite. DA is opposite of AD, and so we're going to use a negative, right? That's why we have a negative AD here. So DA is actually equal to negative AD because we're heading in the opposite direction. And so we have that DA equals to negative AD. We're going in the opposite direction. But what is AD? We know what AD is. AD is 3B minus 2C. And that's what they told us here. AD is 3B minus 2C. And so we insert AD here. What about this AC, right? What about this AC? What is AC? Remember, in the previous question, we saw that AC is actually equal to 6B plus 6. And so we just insert the expression for AC. So AC is 6B plus C. Now let's consider this expression here and let's simplify it, right? And so what we have here is we have basically a negative 1. You can think of this as a negative 1 out front. And we're going to multiply that by the 3B. We have a negative 1 multiplied by 3B. And we have, I noticed that I put the same thing twice. That is to say that this line and this line is repeated. And so we don't need to have it twice. So let us move one of them. Let's move one of them. And so let's erase. So let's move one of them. So it's going to be, let's move this one, right? Because they're the same thing, right? So let's move that. So in your answer, just move from here to here. Okay, so again, let's consider this to be negative 1. So we have a negative 1 out front, and we're going to multiply that negative 1 by 3B. So we have negative 1 multiplied by 3B, that's going to give us negative 3B. And we have negative 1 multiplied by 2C, and that's going to give us a negative, and a negative is a positive. So we have positive 2C. Okay, and then we just bring down the 6B and the C, and so that we bring that as follows. All right, so what are we going to do next? Next, let us try to group our like terms. And so we see that we have a B, 3B here, negative 3B here. So let's bring that down. And we notice that we have a 6B here, this positive 6B. So we're going to bring that over here together with the negative 3B. And what about our plus 2C? Notice that we have plus 2C and we have C here. And so what we have here is we're going to bring down the 2C and then we're going to bring down the C. And so we have these things grouped together now. So we have a negative 3B plus 6B. And what is that? What is negative 3 plus 6? Negative 3 plus 6. Well, negative 3 plus 6 is the same thing as saying 6 minus 3. What is 6 minus 3? 6 minus 3 is 3. And what is 2C plus C? Well, you can think of the C as having a 1 out front. And so 2C plus 1C is actually equal to 3C. So DC equals 3B plus 3C. All right, awesome. So now let us consider the next question, which is B triple I. And it says, write down two geometrical properties of AB and DC. Write down two geometrical properties of AB and DC. So let us consider that. Note that, remember from our previous question, DC, we saw that DC is actually equal to 3B plus 3C. And so that's what we have here. DC equals to 3B plus 3C. Now, if we were to factor out a 3 here, right? So that means we're pulling out the 3. Then we can write this expression like this. Now, all this is that they're the same thing. We just write it a different way. And so we have 3 times B, which is the same 3B, and 3 times C, which is the same 3C. And so we have DC equals to 3 times B plus C. This is just another way to write it. But remember, what is B plus C? Like, what is that? Did we saw that somewhere? Is that what is B plus C, right? What is B plus C? Notice that in the question we saw that AB is actually B plus C, and if you look at the diagram, AB is indeed B plus C. So B plus C is actually equal to AB, and AB is equal to B plus C. And so since we have B plus C here, that's actually equal to the vector AB. So there we have it. DC, the vector DC is equal to 3 times AB. Now, what does that mean for DC to be equal to 3 times AB? Well, since DC is equal to 3 times AB, this means that the vectors DC and AB have the following geometrical properties. What are these properties? Now, since DC is equal to 3 times AB, then that means, by definition, that means that the vectors DC and AB are parallel, right? They are parallel because remember what it means? Because to be parallel, two vectors are parallel if there exists a number that we can use to multiply by one vector to get another vector. Again, two vectors are parallel if there exists a number that we can use to multiply by the other number to get the next. So if there exists a number that we can use to multiply by the other vector to get the next vector. And that number is 3, right? 3 multiplied by this vector gives us this vector. And so that means that these two vectors are parallel. So the vectors DC and AB are parallel. The next thing that we can get from this equality, from this equation, is that the vectors DC and AB are scalar multiples of each other, right? They're scalar multiples of each other. And the scalar here that we have is 3. So the vectors DC and AB are scalar multiples of each other. What does that mean? Well, if they are parallel, then they're scalar multiples of each other. And that's what it means to be parallel. If you're parallel, you're scalar multiples of each other. And if you're scalar multiples of each other, then you're parallel. So me saying that they are scalar multiples of each other is another way of saying that they are parallel. Okay, number 3. The vectors DC and AB have the same direction. They have the same direction because let's look at it. Let's look at the diagram. AB, right? AB. So this is the vector AB. And the vector AB, let's make a note here. Let's use, say, purple. The vector AB is heading in this direction. Right? It's heading upwards. And DC is also heading upwards. And so we can see that they have the same direction. So the vectors DC and AB have the same direction. And that's because of this expression here. And the diagram just gives us a intuitive feel for it. It helps us to see it, just to visualize what's happening. And finally, the vector DC is 3 times longer than the vector AB. And we can see that. DC is equal to 3 times AB. Okay, so we've answered BI, BII, and BIII. So that brings us to the end of this video. Thank you for your time and attention, and I'll see you in the next video.